want to thank the EIF and Carlos for inviting me along to talk to you guys. My name is Ray McConnell. I'm the CTO of Blue Wireless Technology in the UK. I'm an engineer through and through, in many years in a number of startups, and I've been working lately with millimeter wave technologies. WiGig, we use 60 gigahertz band. 60 gigahertz band is around 9 gigahertz of spectrum. 9 gigahertz of spectrum is more spectrum than all the other radios you've ever heard of. So that's the size of the spectrum. The amount of performance that you can get out of a WiGig technology is enormous. Okay, so let me just talk through the document I printed out earlier on. So 5G, 5G is a networking technology. It's not just a radio technology. Things have moved on, which means that 5G can encompass any radio technology. Any radio can be seamlessly integrated into 5G. And in fact, if you have an iPhone, you may not realize that your iPhone will switch seamlessly between an LTE and Wi-Fi. You may not realize that's happening, but it works on your iPhone today. So Wi-Fi can be seamlessly integrated into the conventional networks that are today. Wi-Fi is ubiquitous. It's everywhere. It's very low cost. And the benefit it has is that it uses unlicensed bands. So there's no costs being passed on to users to pay for expensive spectrum. And the spectrum is quite large, as I've just pointed out. But really I'm here to talk about WiGig. Now WiGig is an extension to Wi-Fi. It's really about point-to-point streaming, cable replacement technology. And the performance that you get out of WiGig, it starts at a gigabit but can stretch way past 10 gigabits per second. And going forwards, we'll probably see 30 to hundreds of gigabits on millimeter wave technologies. And I've brought an antenna with me as an engineer, so that's what sort of thing I would do. This is a 300 meter antenna for a WiGig baseband unit. So this will push 2 gigabits per second over 300 meters. So one can imagine building a network of these components, constructing meshes that can extend over several miles, multiple kilometers. In fact, we have a customer in the US building networks and competing with cable using this technology and is able to deliver gigabit access, gigabit internet to home users at very low cost. So a box integrating these components, $350, which is very cheap to build effectively a wide area network. It will plug into a fiber pop or even a satellite connection, so you can extend the network as wide as you wish. Okay, so this technology really is an ideal not-spot technology. It really allows very low-cost components or routers to be placed on lampposts, on top of roofs, against buildings, in the same sort of costs you would expect when you buy yourself a Wi-Fi AP, and you bought one of these things. Everyone must have one at home, less than $30 or so. For those sort of costs, users can ad hoc create their networks and supply themselves with gigabit access. Doesn't need any fiber to dig up the road. You need and it's much faster than any copper connection. So the gigahertz domain is a new area of radio technologies and has an enormous opportunity in terms of being able to supply very low-cost radios to not spots. Of course, 5G networking is really about extending the functionality of networks. So the SDN, NFV kind of technologies are really about placing applications close to where the radios are. So essentially, we call this MEC, which is essentially an offload technology. So if you want extremely low latency, for instance, interacting with a moving vehicle, these MEC, or these compute entities inside the network, up the lamppost, is the right place to do that compute. It's less than milliseconds to actually access those pieces of technology. And because it's a soft approach, you can cast down these applications and run them where they need to be. So in summary, cheaper than fibre, you don't need to dig up the road, faster than copper. Copper really is squeezing the last parts out of copper nowadays. Millimetre wave has very high performance, very low cost, and has a bright future in terms of being able to supply technologies and internet to hotspots in rural communities.
Thank you. Thank you very much.